Welcome to the Best Practice Series. My name is Barbara. I'm the Application Engineering Manager for the VersaPass products at memjet. In this webinar, we will focus on how to best optimize your print quality and printhead life by managing the single largest factor that influences these, and that is keeping the printhead nozzles in a healthy condition with proper maintenance of the printhead itself and the printing system. There are several factors that influence and impact print quality and printhead life, so we have a series of webinars addressing different topic areas. One of the objectives of these webinars is to provide you with hands-on knowledge that you can directly apply. As I mentioned, in this webinar, we will focus on the largest factor, which is system maintenance and servicing of the printhead. These are the actions that best ensure that all the printhead nozzles are kept in optimal condition, which includes being kept clean, hydrated, and temperature maintained in a frequent, random, and consistent fashion. These are key to attaining the best print quality and consequently the longest printhead life. We will cover system maintenance elements that are better and cheaper actions than just replacing another printhead. Actions that can avoid unnecessary interventions, printhead replacements, scrap, and job reruns. I'm going to start with a precept, and that is the means to better print quality and printhead life are through actions in your control. If you don't currently feel very much in control of that right now, please stick with me. My goal is to provide you with insights and actions that place you in the driver's seat of maintaining printhead nozzle health, which is key in optimizing your print quality and printhead life. This in turn goes towards saving you time, money, and customer calls. Let's get started. One of the best practices is changing out the microfiber roller every time you change out a printhead. You may hear the microfiber roller, also called MFR for short. If you're asking, is it really necessary to change out the MFR that often? Let's think about that. If you were cleaning the windshield of your car, would you try to clean it with a dirty towel? No, of course not. You know that would result in smears, streaks, and smudges. You would have no expectation of obtaining the clearest visibility that way. The MFR is a consumable, and as such, it needs to be exchanged for a new one on a regular basis to maintain optimal print quality results. The MFRs go through a lot, and they are accumulating more than just ink. They end up collecting dust and debris from the environment and the air, along with paper fibers and dust from the media running past, and everything that is cleaned off the printhead surface. There is more paper dust and particulates in a typical printing environment than most folks think about or expect, and that ends up on the MFR and the printhead surface as well. This can be a large contributor to white streaks. In addition, MFRs wear over time from being wetted and dried through many cycles. Think of how a paint roller is just not as effective after repeated use. If you are installing a new printhead, it just makes sense to start with a new MFR so you have a known clean starting state, especially if you've been struggling with print quality issues. Also, the new combination is cheap insurance for ensuring optimized print quality, since the cost of the MFR relative to the printhead is much less expensive than multiple printheads. I'll end this topic with the car analogy that worn tires can lead to poor driving situations, especially in bad weather. But it doesn't mean that your car engine's bad. A worn or excessively used MFR can lead to less than optimal print quality, but it doesn't necessarily mean your printhead is bad either. As simple as use the recommended printhead maintenance routine seems, we see too many instances where the user has in fact disabled or minimized them, thinking they are going to gain throughput. Ironically, it's just the opposite that typically occurs, with more print quality issues arising because the printhead nozzles are not being properly serviced. The printhead maintenance routines should never be disabled and need to be appropriately used for the job situation. The basic but fundamental verification that the recommended maintenance routines are occurring is like verifying that there is gas in the vehicle or the computer is plugged in. It saves a lot of troubleshooting time when they are inadvertently or improperly set for the job situation and environmental conditions at hand. Each of the maintenance routines has a purpose towards keeping the printhead nozzles in optimal condition for reliable and consistent printing. It is similar to having routine scheduled maintenance, oil changes, and tire air pressure checks done to ensure your vehicle will perform reliably and consistently. These in turn ensure that you get the most miles from your engine and tires. Proper printhead maintenance and care ensures you get the most mileage out of your printhead as well. Let's cover how each of these maintenance routines serves an important function. The beginning of job maintenance routine ensures clean and properly hydrated nozzles to give you a good first print. You may need to adjust this servicing if you start to see streaks or signs of dehydration quickly into the print job. The keep wet spitting and the mid-job maintenance routine settings keep the printhead nozzles clean and hydrated throughout the print job in different ways. These are especially important optimizing dials that we're going to go into further detail on in just a moment. The end of job maintenance routine ensures that the nozzles are properly conditioned at the end of the job so that they're put back into the printhead cap in a ready state for the next job. This may be adjusted if the end of job and beginning of job typically occur very closely together. The idle maintenance routine ensures nozzles stay hydrated and clean during longer idle periods. Nozzles can become dehydrated even when the printhead is parked in the maintenance module capping station and properly sealed if the printer's in a drier region or season with lower relative humidity. In that type of situation, idle maintenance may need to occur more frequently to combat issues with streaks, voids, and color variation upon printing startup. As external driving conditions change, you make adjustments to re-optimize your driving experience for those. For example, to maintain good visibility in stormy weather, you may need to adjust the windshield wiper frequency or adjust the defrost control to keep it from fogging up. The need to make these adjustments may be temporary as the weather changes, seasonal or situational as your location changes. Mid-job and keep wet spitting are user settings to maintain nozzle health by preventing dehydration and contamination of the nozzles throughout and during the print job. These are the primary printing system settings that can help counterbalance external condition changes that can impact printing performance. These include changes in the ambient temperature and humidity, variations in environmental cleanliness, or media cleanliness or media properties, changes in ink profiles used for different media or job content, changes in printed image content and coverage, and differences in customer print expectations and needs. So troubleshooting of print quality issues should always start by evaluating whether any of these external items may be the root source of that issue. In the short term, a new printhead may appear to address issues that are really caused by some of these external conditions or changes to them. But in the long term, if maintenance is not re-optimized for that change to maintain printing performance, the issue will be back soon enough. When troubleshooting, remember that external condition changes can be seasonal, regional, facility, or print job related. I encourage you to also watch the Best Practice Series webinar on addressing common print quality issues. In addition to talking further with your technical support representative, if you're having a change in print quality and need assistance in analyzing what external factors may be more problematic and how to best adjust for those to bring back that optimal print quality. When the health of the nozzles is not taken care of along the way, additional longer recovery servicing is needed and/or a faster rate of degradation of the printhead can occur. You will likely end up needing to replace the printhead earlier than it would have needed to be, and this may not be the trade-off you had intended to make. Ignoring conditions like the relative humidity being very low or the printing environment being very dusty and uncontrolled is like ignoring a tire on your vehicle that needs air badly, but you keep driving on it anyway. If it's low enough, you will damage the tire as it wears unevenly and your gas mileage will be impacted. the tire needs air put into it when it first goes low and while the mileage is being put onto the tire, not after the fact when it's too late. Mid-job maintenance is similar to stopping to put that air into the tire, and the frequency should be doing it when it needs it. Again, you always want to start with the default settings and adjust from there. From the default frequency setting, some examples of where potentially you may be able to back off the frequency of the mid-job are in situations where the media cleaning is part of the printing process, or the printing environment conditions are more controlled, or your ink media interaction allows it. If you're having print quality issues, especially streaks, you need to consider if any of the following may be in play and warrant an increase in mid-job frequency. Situations like relative humidity that's out of the nominal 40 to 60% range. This is one many folks underestimate how much this changes in some regions on a seasonal basis. Just as the extra dryness or humidity doesn't feel good on your skin, it can significantly change the printing zone ecosystem. Use of low dot gain medias such as synthetics or glossy medias may need a greater frequency to deal with additional aerosol that's not being absorbed, or lower quality medias that tend to shed more fibers and paper dust that end up landing on the printhead surface. Environments that have a large variation in air cleanliness quality with more dust, dirt, pollen, pollutants that float around or build up on the equipment and media. High environmental temperature can cause faster dehydration to occur. High coverage print content can cause heavier aerosol conditions, or very low coverage print content where many nozzles are exposed to dehydration from not being used very often may warrant a more frequent mid-job servicing need. Another key adjustment for keeping print quality more consistent as external conditions vary is the Keep Wet Spitting Frequency setting, or KWS. While printing, minimal random spitting occurs on all the nozzles to assist in keeping them hydrated, cleaned, and cooled. This is especially beneficial in maintaining print quality and printhead life in situations where many of the nozzles are not used as often as others during printing. This is typically due to image content, jobs with low print coverage, or that are very repetitious, with limited nozzles being used and just occasionally printing with others during long runs. I recommend that you also view the Best Practice Series webinar on the impact of print content and usage on print quality and printhead life for further understanding on this topic. Other situations where greater KWS frequency may help are with lower relative humidity environments, or environments that see larger swings in temperature and cleanliness. Staying with the car analogies, using the appropriate KWS frequency is like the difference between using an automated car wash and letting the kids wash the car. With the automated car wash, you get a good result because the right amount of water and soap is used all over the car at the right times. There's consistency. With the kids washing the car, the results are not going to be as good realistically. There will be areas where the soap did not get rinsed off before it dried on. There will be more inconsistency in all the dirt and bugs getting scrubbed off. It will be cleaner, but likely with some water spots and not as uniformly clean. KWS is useful in troubleshooting print quality streaks that could be caused by dehydration and/or contamination, especially if that problematic area is where the nozzles are considerably less utilized relative to others. If turning the frequency of KWS up helps the print quality issue, dehydration or external contamination are probably your cause rather than the printhead itself. You will want to note that the default for DG ink is not the same as the default for DN ink. Here are some additional examples of other ways to combat dehydration, which is a common environmental situation, and further increasing KWS is not always an option. In the first picture, we have KWS turned up. Some alternative tricks are printing a sacrificial print spit line at the start of the print if there's post-processing later anyway. It can be printed in the matrix area between labels or die cut out. or modify the image artwork to incorporate the KWS intent. This can help keep the printhead nozzles healthy for longer runs or in tougher environments. In this first example, the border and the dividing lines act as integrated print spit lines and serve as part of the artwork design. In this example, the direction of what gets printed first can help clear nozzles at the start of the print with the darker tones that utilize more color channels and nozzles. Lastly, controlled humidification in the printer area can bring the relative humidity into specification and assist with problematic dehydration situations that are regional or seasonal. And finally, we come to the importance of performing routine preventative maintenance. This is opposed to reactive maintenance or repair, which no one likes since it always occurs at a bad time. It should be like the 21-point vehicle inspection you have done to keep it running optimally and reliably and to avoid the breakdowns. Your technical support representative will have more details, but here are some basic items to check during your maintenance inspections. Inspect and replace the MFR at a regular frequency. We talked about replacing it along with any new print head, and that's an easy way to track the status of that one. You will want to check it also if print quality issues such as streaks start occurring. Remember, you would not expect a clean window if you were cleaning it with a dirty rag. The printhead nozzle surface is the same situation. Inspect and clean surfaces around the print zone to eliminate ink aerosol buildup, which can cause smudging, ink or color mixing, streaks, intermittent issues, and more. Remember to only use lint-free cloths and clean, sterile, deionized, or distilled water. This is to ensure you're not introducing more fibers and contamination. Regular water can contain minerals, lime, chlorine, and unintended contaminants that can cause problems. Inspect the PPCA board and the printhead connection points. Visually inspect the printhead contact pads for signs of excessive wear, oxidation buildup, and dried ink drips, or fibers and anything that could prevent clean contact. On the PPCA board side, visually inspect the spring contacts for any bent or ununiform pins that could prevent consistent and uniform connection. Inspect the printhead cap for cleanliness and proper sealing. Issues with either of those can cause dehydration and streaking from either contamination or air infiltrating in. Inspect the revolver seals, where the printhead makes its fluidic connection into the rest of the ink circuit. Inspection with a mirror should reveal round, even circular openings into the revolver. If the shape is not circular, the seal's been improperly smashed, or it could be torn or damaged. It needs to be replaced, as that could be the cause of air leaking in and causing streaks. Inspect the ink tubing circuit for signs of air leaks. Some air bubbles is expected. Lots or a change in what you're used to seeing is a flag to inspect things further, especially air bubbles collecting at the inlet side of the printhead, which can cause streaks, drips, color mixing, and other print quality issues. And finally, inspect to ensure that the printhead communication cables are securely latched and connected, and that tie wraps or other pinch or wear points have not damaged any of the cables in any fashion. This type of damage can cause intermittent issues that are hard to track down. As we wrap this webinar up, here are some of the important takeaways that hopefully you captured. Appropriate and regular maintenance of nozzle health directly impacts printhead performance, print quality, and printhead life achieved. Ignoring them will be detrimental to your results. Maintenance elements are primarily user-controlled through appropriate best practices and printer system settings that should be adjusted as environmental condition variations may warrant. Avoiding dehydration and contamination of the nozzles is vital to optimizing printhead health. Understanding what helps or hinders that better prevents issues and the troubleshooting of them. The more consistently the health of the nozzles is maintained, more optimal printhead life will be achieved. I hope you now do believe that there are many actions you can take to optimize your print quality and printhead life results in your different applications. I wish you time, money, and customer calls saved with the further insights you've gained today. Thank you for your time and attention, and stay tuned for more webinar topics to come. We would greatly appreciate your feedback and a quick survey at the URL shown. It's also a way to provide input on future additional topics that would be beneficial to you.